Additionally, virtual reality (VR) experiences use 3D terrain mapping to create immersive environments for users. The use of 3D terrain models is not limited to Earth either. Recently, NASA has been using this technology to study Mars and other planets. By creating 3D terrain models of these planets, scientists can better understand the surface features and topography. As 3D terrain mapping technology continues to evolve, new applications for this technology will emerge. For example, the rise of autonomous vehicles may lead to the creation of 3D maps of road networks that are used for navigation. This could help to improve the accuracy and safety of self-driving cars. In addition to LiDAR, other technologies such as photogrammetry and satellite imagery can also be used to create 3D terrain models. Photogrammetry involves the use of photographs taken from different angles to create 3D models of objects and terrain. Satellite imagery can be used to create 3D models of large areas, such as entire cities or regions. In recent years, there has been a growing interest in the use of virtual and augmented reality (VR/R) technology in conjunction with 3D terrain mapping. By combining these technologies, users can experience realistic, immersive environments that allow for exploration and analysis of terrain features. For example, VR/R technology can be used to create virtual tours of important sites or natural landmarks. Users can explore these places as if they were actually there, gaining a better understanding of the terrain and its features. Additionally, VR/R can be used in education to teach students about topography, geology, and other related fields. One of the most useful applications of VR/R and 3D terrain mapping is in the field of emergency response. By creating virtual simulations of disaster scenarios, emergency responders can better prepare for real-world events. They can also use these simulations to develop and test new response strategies in a safe environment. While the combination of VR/R and 3D terrain mapping is still relatively new, it has already shown great potential in a variety of fields. As technology continues to improve and become more accessible, we can expect to see even more innovative applications for this technology. Furthermore, the use of 3D terrain mapping is not limited to professionals in the field. Many hobbyists and enthusiasts are also taking advantage of this technology to explore and visualize the world around them. One popular application for hobbyists is in the creation of 3D printed maps. By using 3D terrain mapping software, users can create digital models of their favorite landscapes and then print them in 3D. These models can be used as decorative pieces or as educational tools for teaching children about topography and geography. Another hobbyist application of 3D terrain mapping is in the creation of custom maps for tabletop gaming. Using 3D terrain mapping software, gamers can create detailed maps of their virtual worlds, complete with mountains, rivers, and other features. These maps can then be printed or displayed on a computer screen for use in gaming sessions. As the use of 3D terrain mapping becomes more ubiquitous, new challenges and ethical considerations will arise. One issue that has already been raised is the privacy concerns that arise from the collection and use of data to create 3D models of private property. The use of LiDAR technology, for example, can collect detailed information about the features of a property, including the layout of the building and the surrounding landscape. This data could potentially be used for nefarious purposes, such as aiding in criminal activity. Another ethical consideration is the potential for bias in the data used to create 3D terrain models. If the data used to create the models is incomplete or inaccurate, this could lead to bias in the resulting maps and models.